Alright guys, so now that we've kind of already reviewed linear and exponential functions, today and kind of the rest of the year what we're going to be focusing on is quadratics. Right? So we already talked about quadratics in our previous unit as being any polynomial where the highest degree is 2. Right? And so here, when we have a function f of x equals x squared, this is the simplest form of a quadratic function. Right? There's nothing in front of the x squared, there's nothing being added to it. Right? X squared, this is the simplest form of a quadratic. Right? And so today we're going to look at not only what the graph of that looks like, but we're going to look at how we can change that and how those different graphs look as we go through. So, and as we go, we're going to go ahead and take a look at the table of values. Then there's a few definitions that we're going to talk about as well. Right? So, first off, remember to evaluate functions. If I have f of x equals x squared, to evaluate this when x is negative 3, remember we are simply just taking the x squared and we are putting negative 3 in. So we are going to evaluate this for negative 3 squared, which is 9. So what that means is when the x is negative 3, my y value is 9. So we'll have that point that we'll put on our graph here in a minute. Then we do negative 2. Negative 2 squared is 4. So we'll have the point negative 2, 4. Here, negative 1 squared is a positive 1. Right? Negative 1, 1. Right? If you were putting these in your calculator, or when you do this later on, always make sure that you put a negative in parentheses, right? Because if you don't, it'll tell you that this is a negative 9, right? But we know that whenever you multiply two negatives, it gives you a positive. So just make sure that if you put that into the calculator, you use parentheses. Right? 0 squared is 0. The ordered pair is 0, 0. 1 squared is 1. Ordered pair 1, 1. 2 squared is 4. Gives us the ordered pair 2, 4. And 3 squared is 9. Ordered pair 3, 9. Okay? Alright, so we're going to go ahead and take these points and plot them down here, and then we'll talk about some of these definitions. So at negative 3, my point is 9. That's way up here off the graph, so we'll just kind of put a point up here. Negative 2, 4. Negative 1, 1. 0, 0. Okay. 1, 1. 2, 4. And 3, 9. Once again, way up off the graph. Right. So this right here is going to be the shape that quadratics take. Right? It looks like a U shape, right? This shape is what we call a parabola. Okay, a parabola. It's the shape of a quadratic function. Anytime you have a quadratic with a degree 2, it's going to look something similar to this. It's going to be like a U shape, right? So the next thing, there are some key features that we're going to talk about this. Just like we did with linear, where we talked about the y-intercept, we talked about slope. Quadratics have key features as well, all right? But there's a couple more. The first one, and probably the most important, is the vertex. Right? The vertex is the highest or the lowest point of a quadratic function. So right here, right, if we look at our graph, this right here, this is our vertex. Okay? And so for this particular one, it's the point 0, 0. Okay? It's at the origin. Right. The next one is the axis of symmetry. Okay, this is the vertical line that divides a quadratic into two congruent halves. Right, so there's a vertical line right here. Okay, and notice that it divides it into half. So if I were to take my paper and I were to fold it over, they would lay right on top of each other. Okay, so like I have a point here, it would lay on top of the other point. Okay, this point right here would lay on top of this point. All right, my 9s up here, those would lay on top of each other. Okay, that's the axis of symmetry. Right? When we talk about the axis of symmetry, not only do we use a dashed line, okay, but it also is kind of an invisible line. Right? Remember, vertical lines, these are lines x equals, and you're going to take whatever the x value of the vertex is, and that's going to be the equation. So axis of symmetry is x equals 0. Right, the next key feature is our interval of increase. So the interval of increase, this is the part of the graph where the y values are increasing. Okay, so if we look at our graph, we go from left to right, we're going down. So this is going to represent the interval of decrease. But where the vertex, that's the lowest point, we start to increase. So how do we say this? Well, we say it's increasing when our x values are greater than 0. Okay? So after the origin, when our x values are positive, that's when it starts to increase. Interval of decrease, where the y values are decreasing, okay, is this area right here. Right? As we go from left to right, my graph is going down. So we say it's decreasing when x is less than 0. Okay? So the axis of symmetry is x equals 0. Right? We are increasing when x is greater than 0, decreasing when x is less than 0. Okay? The domain is the list of all of the x values of a function. Right? So if you look right here, we just have from -3 to 3. But with quadratics, we're going to say that the domain is all real numbers. Okay? All real numbers. Okay? Now the range is a list of the y values. Okay? So if you look, notice that our y values, we have 0, 1, 4, and 9. Notice that there's no negatives in this one. Okay? You can also see this from the graph, because the graph never goes below the x-axis. So our range, our y values, are greater than 0. Okay? Basically meaning they're positive in this one. Okay? And it'll change a little bit as we go through. Okay? All right, so this is the basics of a quadratic function. Right? So what I want you to look at, if you actually go ahead and flip over to the very back page. Right? So we're going to skip over this next page right here. We'll come back to it. And I want you to flip over to the very back. Right? So I want to take a look at a couple graphs here and just look at those key features just by looking at the graph. Okay? So on this first one we want to identify. We want to identify the vertex. Okay? So the vertex is the lowest point. Okay, that's my vertex. And it is the point -2, -2. Okay? The axis of symmetry is the invisible line that goes through, that folds it in half. Okay? And this is the line x equals -2. Okay? Increasing. Okay? We're coming down, we're going up. So this time, notice where the vertex is. We're increasing when x is greater than -2. Okay. All right, and we're decreasing when x is less than -2. Okay. We're decreasing on this side when x is to the left side of the vertex, right? We always use those x values. The domain, okay, once again, the domain is always going to be all reals. Okay? And one way to find the range, because the range is a list of y values, if we find the lowest point on the graph, where the vertex is, right? We're going to say y is greater than, actually it's going to be greater than or equal to -2. Right? I need to fix that up on the front here. When we talked about our range on this one, the range this should have been y is greater than or equal to 0 as well. Okay? Because the reason why we say greater than or equal to is because the graph comes all the way down to that point. Same thing over here. The range goes all the way down to that point. Okay? All right, we're going to take a look at one more of these, and then we'll take a look at that next page. All right, vertex. Okay, now this time notice my vertex isn't the lowest point on the graph, but instead it's the highest point. Okay, and so here that's going to be the point 3, -3. All right, my x value is 3, my y value is -3. The axis of symmetry, okay, is right here. And this is the line x equals 3. Now this is where it kind of gets tricky because you're used to saying, like with the intervals of increase and decrease, but if we follow the graph from left to right, okay, from right here, I am going up, right? So where are we going up? On what side of that axis of symmetry? We are to the left. So we are increasing when x is less than 3. Okay. We are decreasing on the other side. After we pass the vertex, we are coming down, and we are decreasing when x is greater than 3. Okay. Now, once again, the domain is still all reals, but this time the range lists of the y values. Okay, we don't have a table of values, but I can see that the highest point of the graph is right here. So my graph, the y values do not go higher than -3. So we say our range is y is less than or equal to -3. Right? Notice the difference. Over here, because our graph went up like this, we said the range was y is greater than or equal to -2. But here where it goes down, the range is less than or equal to -2. Okay? So one of your assignments today is simply just going to be looking at identifying the key features here. Right? So if you guys will turn back to the second page, take a look at example 2, and then we will finish these up. All right, finish the notes up so you can work on, you have 2 assignments to be working on today in class. All right, so we'll finish these up here. All right, so what we want to do now is, so we have an idea of what the graph looks like when f of x equals x squared, right? So the basic form of a quadratic looks like this, okay? However, what happens when we have a number out in front, okay? So we're used to calling this a when we were factoring, right? Because we had to use that as part of our factoring tool. So we're going to look at how this affects the graph when we do this, okay? So we've got another table of values, okay? So we're going to compare these two. So the same as before, I'm going to say 2 times -3 squared, okay? But this time we're going to square the -3, which gives us a positive 9. 2 times 9 is 18. So when x is -3, y is 18. We're way off the graph, right? So I'm like way up here. -2. 2 times -2 squared. This is 2 times 4, which is 8. So 2, 4, 5, 6, 7, 8. We're like right here. X is -1. We're at 2 times 1, which is 2. So 2, 2. At 0, 2 times 0 squared. 0 squared is still 0. 2 times 0 is 0. Oh, I put this point in the wrong place. It should be at 1. Okay. Now, I want to show you a trick. We're going to go ahead and fill out the table of values here, but I want to show you a trick when we're graphing these, right? And you'll be able to use this later today. So I'm going to go ahead and fill this. So 1 squared is 1. 2 times 1 is 2. 2 squared is 4. 2 times 4 is 8. 3 squared is 9. 2 times 9 is 18. Now remember how we talked about how these have an axis of symmetry? Okay. Notice right here that 0 is kind of right in between these 2 points. Well, here these actually have an axis of symmetry going right through here. And if you know where the vertex is and you know where the axis of symmetry is, then you can take these points and you can actually just reflect them. So this is 1 point away, this is 2 points away, this is 3 points away. Alright, so my graph is going to come down through here and then up. Okay, this one is our f of x. Right, this is this one right here. Okay. Now let's take a look at the next one. This one is 0.5 times x squared. So we're going to say 0.5 times -3 squared. That's 0.5 times 9, which is 4.5. Okay, so when x is -3, y is 4.5. 0.5 times -2 squared. It's 0.5 times 4, which is 2. So at -2, we're at 2. 0.5 times -1 squared. 0.5 of 1, which is 0.5. Right. 0.5 of 0 is 0. Okay. Finishing up this table, 0.5 times 1 squared, 0.5 times 1, which is 0.5, 0.5 times 2 squared, it's 0.5 times 4, which is 2, 0.5 times 3 squared is half of 9, which is 4.5, right? So when x is 1, it's 0.5. When x is 2, it's 2. When x is 3, it's 4.5. Alright, so notice the difference, okay? The big thing, the point that we want you to take away from this, okay, and we'll skip the key features here since we talked about them so much before, is that when the number in front is larger than 1, like it is in f of x, your graph is going to be more narrow. Okay? It's going to be more narrow. It's going to be skinnier. Okay? When your value is less than 1, like it is in g of x, right? It's going to be more wide. Okay? Or it's going to be fatter, if you will. I don't know if that's how you spell fatter. Maybe there's 2 T's. I think there's 2 T's. Okay? So if it's greater than 1, it's narrow. If it's less than 1, it's more wide. On your online assignment, there's like 6 questions, and all of them are basically you are trying to determine whether or not the graph is going to be more narrow or more wide. So if the number you're multiplying by is greater than 1, it's going to be more narrow. Okay? So this one is narrow. If it's less than 1, it's going to be more wide. Right? Alright. And we've got one more. So we looked at what happens if numbers are greater than 1, less than 1. The next thing that we're going to look at is what happens if the number is negative. Okay? So first off, 1.5 x squared, we're going to do the same thing. 1.5 times negative 3 squared. That's 1.5 times 9. That is 13.5, and I'm running out of room. Okay, so 1.5 times negative 2 squared. That's 1.5 times 4, that's 6. So negative 2, 6. 1.5 times negative 1 squared is 1.5 times 1, which is 1.5. Okay. And when you make a table of values, when you guys do these on your own, you can definitely use a calculator for these. 1.5 times 0 squared. 0 squared is 0 times 1.5 is 1.5. Oh, sorry, I lied. It's 0. Anything times 0 is 0.
Good afternoon, Lafayette. We do have one announcement.
1.5 times 1 is 1.5. 1.5 2 squared is 6. And 1.5 times 3 squared is 13.5. Right? So we can see right here. Right? So when it's positive, basically that's what I want you to look at right now. We say the graph, it opens up. Okay? Now, the biggest difference is, notice now here, with g of x, we have a negative 1.5. So the only difference, we're going to take a negative 1.5 times negative 3 squared. This is still going to be 9, but when I multiply this, it's now going to make this a negative 13.5. Okay? Here, we take a negative 1.5 times negative 2 squared. This is still a positive 4, but the negative 1.5 makes this a negative 6. So basically, it's going to take all of these values here, and it's just going to make them negative. Except for 0, because 0 can't be negative. Right? So all of these values will be negative. So look what happens at the graph. Right? At negative 3, negative 13.5, that's way off. We won't worry about it. Negative 2, negative 6, negative 3, negative 1. Negative 1, negative 1.5. 1, 1.5, 2, 6. Okay? So, big thing here is when A is positive, when you're multiplying by a positive number, the graph opens up. When it's negative, we say it opens down. Okay? That's the main thing that you're going to be looking at for today, right? So you have 2 assignments to work on today. You have an online assignment that is basically the only questions that it is asking is the graph going to be narrow or wide? Is it going to open up or down? Okay? So you're going to do that online. There are 6 questions, I believe, on that, 6 or 7. And then you have a paper copy where you are going to, you've got to look at some graphs and identify these key features, okay, and then a couple where you have to sketch them, okay? All right, you can still ask me questions if you got questions, but go ahead and get to work.